you. And now I invite Charles Simpson here to my left and Martin De Vos here to my right. Again, I have really to synthesize because you have so many achievements. And Charles is Professor of Clinical Neuroscience at the Department of Neurology and head of the MS Center in Dresden University. And I have to acknowledge he is the first to really develop a digital MS twin. And to my right, we have Martin De Vos, who is a research professor in engineering and medicine departments. And he's also working on the incorporation of smart analytics into wearables. So I look forward to hearing to your experiences and insights on the use of artificial intelligence and remote monitoring data and prompts to reveal MS progression. Please, Charles.
Thank you very much for the introduction. And also, it has been already a great day. Some of the ideas we heard earlier this morning will come back in this presentation. And we took the challenge of doing a joint presentation very literally. And we were going to try to dynamically switch speaker during the talk on this topic. And before we start, we would like to activate a bit the audience. So I was given the challenge, and I didn't have a choice to answer to this controversy. Is it yes or no? But I would like you to all think now a bit, and I will do a poll at the end to see, okay, who would vote yes or who would vote no for the statement AI will change MS care within the next 10 years. And so think about it. So what we're talking about here is really looking for longitudinal markers. And we've seen kind of a non-animated version in the presentation by Matthew already, like any chronic disorder is characterized by a change in symptom severity over time. And this can be for depression or psychological disorder, or it can be for a neurological disorder, it can be for an asthmatic condition or something like this. And also, when, as a medical doctor, when you see the patient, you try to help them, and maybe you aim to stabilize the person, maybe you aim to cure the person for a certain time. But chronic disorder means that you will relapse sooner or later. And so the question then becomes like, how is the disease trajectory going on? Is it looking like this? Maybe it's looking like this, but we don't really know. Or maybe, unfortunately, a person is really not getting any better, and the best we can do is stabilize. So the question is, can we get those markers in between this clinical assessment? We can't get an MRI, a brain measurement every day, but we have all these wearables, smartphones, smartwatches that we can use in order to get a glimpse, maybe more objective, I don't say better, than the personal opinion of the patient. We can do this once diagnosed, but obviously probably the holy grail is, can we even get earlier markers that predict what's going to happen and that we can intervene earlier on.
Yeah, and I think the challenge in clinical practice is that, of course, we can run a lot of clinical trials where we integrate this digital health infrastructure, or to set up really a nice project like Radar. But the challenge is in clinical practice is really how we can integrate it into daily care. And I like this slide a lot because it characterizes my life very clearly. So all clinicians are limited by time, resource, and technology restrictions, and that is our problem. In daily care. So we would have to find a way of how we could integrate, I think, tools to measure MS in daily clinical practice. And I think for this, the remote monitoring, as we have seen already in the very nice Radar CNS presentation, I think it's very relevant for MS as well. And Tizia, you have already introduced that's very suitable for MS as well, because in MS care we have the same problem as we have seen in the depression. So if we see a patient only at two different time points, and we have probably signals in this, it will be very difficult and challenging to identify it only by the regular doctor's visit. And there I think tools to detect it could be quite helpful. So the challenge is, of course, how we could integrate it into clinical practice, because that I think is a major topic of this symposium. So we have seen that remote monitoring, I think, is a helpful tool. And of course, if you put a lot of resources inside, I think everyone sees that it's working. Still, it has its challenges, retention and so on. But the idea is really to have something available which is able to identify subclinical disease activity and progression. And then I think a very important topic is, which we would like to discuss. So, of course, we have already seen active, passive monitoring. I think everyone, every monitoring has its role, but on the other side, it's of course challenging to put this into context. And that's why I like this slide quite a lot, because it really demonstrates you the possibilities we have. Of course, we start on the left with clinical examination, which should be done by every neurologist, and on the other side we have a little bit like we have seen with the smartphone, but the connected smart application. Yeah, so you went in your bathroom in the morning and the mirror is seeing, oh, Teams is good again, so no depression tablet necessary. So and that I think is the in between we have. Yeah, so that we have to decide, and probably we have to mix. Yeah, we have to mix between certain active tests and then a passive monitoring, I think, to bring it really to the audience, to our patients.
And obviously, we can debate about the naming of all this e-health and telehealth and so on and so forth, but there is always some notion of AI that is really in the center to harvest some of this data and hopefully give us some new insights. And this also is very high level, but again, it illustrates a bit nicely what is the vision for all we are doing, because somehow on the top you see kind of the idea that some carers are taking care of a patient, and some days it's going well, some days it might not be going well, and they might provide some therapy, some iteration, some update of the treatment and things like this. But sometimes also when they don't respond to even this change, okay, there is a need for an imminent action. And so this vision remains the same, even if there is some AI and some data and some cloud in between. And it really becoming the challenge, okay, how do we integrate now all this technology for remote monitoring and ultimately for disease management into disease pathways? And so to start a bit of this work, we collaborated with Roche on the Floodlight study. And so they collected, they developed this app where they try to digitize kind of a clinical assessment, namely draw a figure 8, draw a spiral, draw a circle, and things like this that are common at the neurological practice in order to think, can we objectify this? And obviously, once we objectify it, we can also do it more repeatedly and hopefully get new insights. And I think from the illustration on the spiral, you clearly see that the way a healthy person, in an ideal case, draws the spiral is very different from a participant suffering from MS. And so this digital correlate is basically not needed to be evaluated by the human, but can be automatically analyzed with what we call machine learning. And so, machine learning in general, we extract some features, we do either a classification or a regression, and in this way we try to mimic the 9-hole peg test with kind of features extracted from the different figures. And we did this both for the dominant and the non-dominant hand, and you see kind of they correlate, probably not surprisingly, because there is an underlying signal. And we've already alluded to, is this 9-hole peg test now the holy grail of upper extremity function testing? No, but it's still the best we have. So I think which of the measures is better for assessing real severity is up for a future debate.
Yeah, so thank you, Martin. I think it's our privilege as speakers that we can, of course, select the field of our interest. And both of us, we realized we are very interested in walking function, mobility, and gait. And we had, for example, in our center the challenge to set up an infrastructure 5 years ago. And my idea and my vision is usually if we set up something that it's not only done in 20 or 30 patients, but when we set up an infrastructure in our center, it has to be done by our patients. And we have achieved, we started 5 years ago with our specific gait analysis, which takes an hour time, and which is, I think, a very nice example of how you can mix up it's a hybrid test. I will explain it in a minute. What does it mean? But we have achieved that. We have now more than 2,500 patients with this data set, so they're tested at least once a year to collect this data. And what I mean with hybrid test, I mean that of course we give direct feedback of the gait analysis back to our patients. That's very important because that is rated. We do extensive evaluation of so-called, not putting the patient PRO story later this afternoon in a context. We are collecting a lot of patient-reported experience because we believe that the patient experience is clue that the test is performed and later on. And we have seen that, for example, telling the patient some results of our test, it's very helpful. So we have hybrid. That means patient is getting instantaneously feedback, and that is loved by the patient, that we can optimize. On the other side, we have a very valuable data set we can use for AI. And I think this combination, on the one side, to give direct feedback and to integrate it in clinical practice is helpful. So we have achieved a lot. And we have, for example, here, as you can see, we have, for example, now a model which is able, for example, with our data set, which our trained data set, to detect, for example, gait abnormalities which are not recognized by the physician, to detect them. Or another thing, for example, in a lot of centers, 6 minutes or 2 minutes walking test is performed, because it's one test of the endurance. What we tried, for example, to use a sensor in combination with this endurance walking test. And the help is that the information you get, if you combine a classical test which is performed in your center, endurance test, 2 minutes, 6 minutes, and you get information by a sensor, so that the value of information you can get is increased significantly, but you have already the test result and which can be used in clinical practice. That's why hybrid, I think, is clue. Martin, you will go in your world.
It's a bit the same world, because we also, on the one hand, in the same floodlight study in the same patients, obviously we want to monitor upper extremity function, but as we all know, also gait is or might be impaired to several levels. And so we also equipped the participants, besides the smartphone, also with a smartwatch. And the reason is simple. All those technology are packed with sensors. They all have a simple accelerometer. Most of them have a gyroscope, and so on and so forth. And the question becomes, can we harvest this data for detecting if a person is being diagnosed with a condition, but even better, what is now the severity level? And so this is some of the data we got. So you see already on the graph, both from the smartphone and from the smartwatch, you get very similar data, because obviously it's the same person walking. This is a healthy person, which we recognize by a low baseline frequency. You also see a nice gait pattern, and that's pretty standard for the healthy controls that were in the study. And with MS, what we see is that this strong baseline at 1.5 hertz is disappearing, and then we get high frequency noise. I don't call it noise, it's the signal that we aim to detect, with kind of gait abnormalities that we can nicely pick up. In our study, we don't have thousands of patients. Obviously, it's the goal to roll it out, but we were quite early and really wanted to have a good proof of concept, and we worked with 100 patients, almost 100 patients in the beginning, which were also patients with very mild MS. And so for this, like if we rely again on features and classifiers, we had like a moderate performance, but it wasn't really blowing us away in terms of accuracy that we could achieve. And then obviously there is this whole deep learning stream where people say, why do you rely on all the features you might think are relevant, but why don't you ask what we call the AI to figure out what features are relevant? And so for this, we reverted to kind of a transfer learning approach where we looked for a big data set, for example, human activity recognition. All of us can be detected, like are we sitting, walking, running, and things like this. And we can extract kind of what are the features, what are the representations that are relevant on a large population from this large data set, and then kind of use these representations for distinguishing the task we're interested in, discriminating healthy people from patients with MS. And this is kind of the representation, the features that I'm talking about, where you see on the left kind of handcrafted features, and this is really the student doing all the effort and using all his imagination to define good features, up to the right where we basically automatically learn the features in order to disentangle kind of the different categories, so healthy controls, patients with mild MS and with moderate MS. And as you see, the representations are being disentangled, which shows that we can characterize them pretty well. The speaker on MR, on brain monitoring also mentioned explainability is important. So we also use a similar technique, layer-wise relevance propagation, in order to then highlight, okay, what of the signal is now driving the changes that we observe in this deep learning in order not to be stuck with a black box model. And then I think what is probably the most exciting part is, so we have all this technology, we can extract some signal, we can analyze it in quite a good way, but the question then becomes, how can we augment clinical practice? So can we really come towards this vision of, can we augment, can we get almost daily or weekly assessments of how well the patient is doing? And here you see some trends that we then collected on a longitudinal basis. You see, this is still an active test, so patients are asked every day, every week, to do kind of this 2-minute walk test, and for a healthy person, you see that they are fairly stable, but they have some days where they look like a patient with mild MS. So the question there becomes already, did he have too much wine? Did he not do the test properly? Or what else was going on? But overall, you see, fairly stable. The same is with a participant with MS, moderate MS. Fairly stable. Once in a while, there is an outlier, this type, in the opposite direction, that he's looking very good. And the question becomes, is this a really good day, or is this again a noisy outlier or someone taking his smartphone and doing the test for him or her? But then the question becomes, so how do we use this? Can we really detect this relapse? Can we detect the change? And so we also asked them to, although this was in a home study, so basically there's very little interaction, but we also asked them for self-reported relapses. And those are marked by strong black lines. And so in the first participant, you clearly see, okay, the person is having mild MS, and the GET signal showing disability is clearly becoming worse, flagging this. So we could think of an automatic feedback loop where this is, obviously afterwards it's also not clear if it's now mild or really becoming worse, but a lot of variation. In the paper there are more examples where we show nice changes of relapse, but the below figure kind of shows another interesting phenomenon. The person is having a very stable assessment, like person with moderate MS, very rigorous doing the tests on a regular basis, and then at a certain moment, like after 8 weeks, you suddenly see that he or she is not doing the test anymore. Afterwards, we notice there are multiple relapses reported in this period between 8 and 12 weeks. So you see afterwards, everything becomes sparse, and so in this case, even the absence of signal is becoming then the signal to be analyzed and kind of the relevance for clinical monitoring. And obviously, how to integrate this patient with the other patients is a whole different debate, but I think those are the hard questions we have to answer.
Yeah, I think we have now seen in a little bit summarizing in both parts, we have seen that remote monitoring, I think, can give really great perspectives. And in principle, it's quite easy because, as Gavin has said, so we all have a smartphone, and in principle, we could do it. But if you're looking, and it's in contrast to drugs, it's really relaxed, regulatory controlled at the moment. Yeah. So, but if you look in reality, I think we see very nice pilots, we see clinical studies, but we have really not a case where it really moved really strongly into clinical practice. And that's why I think we have to be very critical, and we have really to analyze, so what is there. So we have the phenomenon the pilot phenomenon, so we have pilot after pilot, but really to implement it into clinical centers, I think that will be our challenge. I think the question, the problems are, for example, as I have here indicated, lack of solution which is available for all. Yeah, so really to have something which is a standard and which is open and which is open source. I think that is a big issue. Then, of course, again, we have seen nice data in, I think, in both parts of the presentation, but still clinical evidence, I think, is improvable, to say it, and that's of course our challenge, especially when we move into clinical practice. And of course, the problem is the healthcare professional himself, because we did an analysis about digital competence among, but it's probably only in Germany the case, among German neurologists and patients, and the digital competence was tenfold higher in patients than in neurologists. And that's of course not very good if you would like to set up an infrastructure. Just to increase depression, so a little bit more, moving at the end to come to patient-reported outcomes, which I think is an important topic, especially if you have the PROMS initiatives today at 4 p.m. And of course, if you have it in your title, to talk about remote monitoring and PROMS, you should take care, especially with Lisbeth, who's who's looking very carefully what you have said. And the big problem is, if you look really at the analysis, AI in patient-reported outcomes, it's very poor. So literature analysis, I think there are now first studies in oncology, but I'm lucky that we just recently published one, detection of fall risk in MS patients, and that was interesting because we could detect that the patient-reported outcomes were the most sensitive tools using this machine learning and selection ensemble algorithm to detect the fall risk better than, for example, all the assessments. But the big problem is, usually patient-reported outcomes are not collected in a constant way, and if you have a small group of patients and only a short time, it's not working there. That's why at the end, before I'm giving back to Martin, I think the problem is that the collection of structured prompts is not established, is not done in a longitudinal outside trial. That's why the PROM initiative is so important, because we need this initiative. Otherwise, we are not able to have data to be analyzed, so are not done. We have the different PRO instruments. I think it's, again, if everyone if every center has a different set of instruments, so what Giancarlo is always doing, that we have a set of instruments which is used by every center, because otherwise we cannot do AI. So the problem is with AI in PROs, which is a very disappointing field, is really the quantity of data quality, and standardization. And that's why 4 p.m. today is so important. Now back to Martin.
So to conclude, I mentioned we will kind of do the poll. Like, after all, we heard today, this morning in our talk, who would vote for AI will change MS care within the next year, and answer yes. Lots of optimists.
Maybe 5.
Who will vote against? No one dares. So very, very good. I love your optimism. And the reason I put this in is that actually the answer is no. And because I didn't have a choice. Because I ruined my career, obviously, with saying like, no, AI is not going to help. But actually thinking about this, there is so much that you can interpret. I mean, even in the title, like, what is MS care? We give lots of research examples. And we don't really show the translation to kind of the patient. What is artificial intelligence? I mean, we have formal definitions. But for me, the best we do is kind of AI is automated intelligence. We're automating some ground truth, supervised learning. We're trying to mimic some labels given by the expert, and we're basically mimicking all the imperfections. And then the third line of argument is also the holy grail, we've heard it today, is digital biomarkers for prognosis. We don't know how to prognose, so what a time it will take to collect data in a harmonized way across the whole world, have enough patients in order to get the right prognostics, and then afterwards even validate it. Because what we do is we collect the data, we retrospectively analyze it, and we have good ways of doing training, testing, separation. But still, this is not how a new treatment is evaluated in current practice, in clinical practice. So, I would invite the audience to prove me wrong and really change it within 10 years, even if it's 11 years, it's still going to be acceptable.
Yeah, so at the end, because we have now the session before, to close the session a little bit before lunch, and probably there to give you something to digest. And on the other side, I'm German, I like cars. That's why I think it's quite good when we talk about artificial intelligence to have really the comparison which we did on this slide with driving, with automatic driving. So at the moment, level 0, where we are, means the driver processes all information, no technical assistance, and that is at the moment state of the art. So neurologist is at level 0 at the moment. Of course, then we have technical assistance, so that, for example, if your car has the lane keeping, so there are some assistance, and that are some tools we have already available, I think, in clinical practice to help you with decision making. That could be some nice tools with MRI. Yeah, so some intention. Then we have partial information, which is, for example, steering and braking. So there, of course, in the field of medicine, I think it's of course getting problematic. I think we don't have some partial information. Situative automation, that is, for example, so if the road is straight, so we don't need assistance. Of course, it would be nice if we have something in medicine. One could imagine, so if all monitoring data are stable, so we don't need evaluation, then minimal human intervention, that is, the car drives by itself, but you only intervene in specific situation. Yeah, I think that is not feasible at the moment because we don't have the technology, and the full automation we don't want because we need neurologists. Thank you very much.
So thank you very much for this very excellent dialogue that you had, and also for addressing the issue of validation. Before we saw the huge effort that Matthew and Nick showed us to validate technology, which is the first need before we go into research and practice. And also you brought the issue of harmonization, which is the main target if we want to create big data before we even collect them and put them together, so that we have less effort later. So I was wondering if you think you are going to change your type of data collection after your experience, for example, concerning adherence, or if you're already happy with that?
Well, actually, I think, so definitely on the gate, what we show nowadays we get from accelerometry. So we have a very good sensor. It doesn't even matter much which type of accelerometer you take. You need some data matching, data harmonization. So I think, and for me, the big value in this, although everything I showed is what we do in active testing, is that we can measure this in an easy way on a daily basis without any effort. So the hope is really that we can just use the data from our phone, select this 2 minutes of good walking data or good movement data, and then analyze it automatically. So in that sense, I'm happy, yes.
That's very important because as clinicians, we have to choose among different drugs, and now we have to choose among different tools. So being device agnostic is fundamental. And Charles, I was expecting you to say that we lack educated neurologists, but there is effort because teaching is important in collecting big data, but also in handling technology. And in your master, together with Charcot on MS, you're also addressing the issue of educating young fellows since the beginning how to handle this.
Yeah. I think we have several. I think we need education, and what we need as well, we need engagement. So we have to be on the driver's seat to move these processes, because I think that's why Radar CNS is such a nice process, because it's not driven by Google or by other, it's driven by us. And I think that is probably the most important thing. Yeah? We have to be educated, we should get competence, we should do it really in a tandem together with the patient, because we realized it's not working only by when we collect data, but we have really to find a tandem, as we have seen it in Radar CNS, I think, very nicely. So we are on the same boat. We have to do it together, and then I think we can change things. I think that is really very important. That's why this session, I think, has demonstrated nicely what is the power of artificial intelligence in remote data capturing, not in PROs, which is disappointing, but on the other side, which can come in this aspect.
Thank you so much.